Hey everyone, in this video, let's take a look at question 56, merge intervals on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, you're given an array intervals, where intervals of I is the start of the interval and the end of the interval, and we want to merge all overlapping intervals and return an array of the non-overlapping intervals that cover all of the intervals in the input. Okay, so what is that saying? So let me take these examples here and paste them over here. And for this first example, you can see we're passed in 1, 3, 2, 6, 8, 10, and 15, 18. For a lot of these interval type questions, it really helps if you draw a picture. So I've done that here on Paint. So we have this interval here, and I've drawn that on my number line right here. And you can see that clearly these first two intervals overlap. This is the first interval that we get, this is the second one, this is the third one, and this is the fourth one. And we can clearly see that these two intervals overlap. So what do we do about intervals that overlap? Well, we have to merge them. So here we can merge them like this. Just notice what I'm doing. You can visually see how to merge them. In this one, we actually don't have to merge it with anything because it's not overlapping with anything. And same thing here. So what would our ending return be? What would our ending list be? Well, it would be the interval 1 to 5, 8 to 10, and then 15 to 18. And you can see that's exactly what we have here. I'm sorry, there should be 1 to 6, and I misspoke and I said 5, but it should be 6 here. 1 to 6, 8 to 10, and then 15 to 18. Okay, so how do we know that these two intervals are overlapping? You know, we can't draw a picture, but how do we know in code that it's overlapping? Well, let's think about this. In the first interval that we have, right, the first interval that we look at, it's 1 and 3. And because there's no other intervals in our result, since we're just processing this one, then we know that this is basically all there is. We don't have to do anything. Now comes another interval. Now comes the interval 2 and 6. How do we know if this interval 2 and 6 overlaps with this last one? How do we know this? Well, let's take a look here. What happens here? Well, I think we can very easily see that in order for an interval to overlap with the previous one, we must have that the end of the last interval, is after the start of the previous interval, right? The end of the last interval is after the start of the previous interval. What can we maybe write this in code? We could say maybe interval at -1, which is the last one, the ending, which is interval -1 at 1, the ending of this is greater than or equal to the start of the current interval. The start of the current interval. Notice how even if it's equal, we consider that to be an overlap. We can see that in the second question here, the second example, 1 and 4 and 4 and 5, this overlaps to make 1 and 5. So we also have to consider the case where it's equal. Okay, so this is how we maybe know that an overlap has occurred. Now, how do we realize how to create the ending overlap such that it encompasses both of the intervals? Here we can just draw a line, we can just see visually, but really what are we doing in the code? Well, notice what we're doing, right? This new interval that we form, notice how the ending of this new interval is actually this thing's ending, right? It's the second interval's ending. The starting is this interval's starting. So what can we maybe understand from this? Well, what we can understand is that the starting actually doesn't have to change at all. The starting can just be the previous interval's starting. Because these are sorted just based off of starting, which we can see right here when we drew them, we don't actually have to change the starting over here at all. All we have to do is change the ending. Okay, so you might just think that we can make a new interval where the start is the last interval's start time and the end is this interval's end time. But that's actually not entirely correct. What if our interval was maybe something like this? What if it was something like this? What if it ended here? Well, in this case, our interval that we create in the very end should actually end up over here, right? So if you think about it this way, both the start and the end come from the first interval. So let's take a look at this again. What can we really understand from this? Well, we can understand that a new interval start remains same as last interval. But what about the end? What does the end become? Well, end becomes, it looks like it's the maximum of these two, right? It's the maximum of this one and this one. Max of last end and current end. This is what we could deduce based off of our image that we have here. Okay, so now we know how to determine if intervals are overlapping. We know how to create a new interval. Now notice how we're not actually creating a new interval, rather we're just extending this old one. We're just extending this old interval. So we can just directly modify intervals -1 and the ending pointer to be the maximum. So we'll do that. Okay, so one more question remains. Now, notice here that when we were given this list, it was actually sorted, right? It was sorted based off of the start time, 1, 2, 8, and 15. But what if it wasn't? What if it was something like maybe 1, 3, and then maybe we had 8, 10, and then maybe now we had like 15, 18, and then finally we had something like 2 and 6. Well, if we were to just go ahead and follow our logic, then would this really make sense here? We would have, what do we have here? We'd have intervals -1 at -1 is greater than the start time. If this 18 is greater than the start time, sure. But then we would go ahead and we would try to merge these two intervals, which is not really correct here, right? Because these two shouldn't even be overlapping if you think about it. These two, the second interval here, actually overlaps with the first one here. It does not overlap with this last interval here. But if we were to use our logic, then it would do that. So how can we get around that? Well, with a lot of these interval type problems, it would often be useful. And often the trick here is, at the start, you would go ahead and you would sort the intervals, often by start time. And here we can see the start time actually just plays the exact role that we needed to play. So let's go ahead and do that. We'll go ahead and write our function. So let's go ahead and start off. So what do we have? The first thing we want to do is go ahead and sort the intervals. So we can do that as follows. So we can use intervals is equal to sorted intervals. And then we can use key as a lambda x, x at 0. This will basically sort according to x at 0, where x is like one of these, and x at 0 is the starting point. Okay, so now let's define a result variable, which will store the ending intervals, and we will return this in the end. So now, let's go through intervals. So for start, end, in intervals, well, if there's nothing in result, right? If there's nothing in result, we can just go ahead and add this current interval. If not result, then result.append, start and end, right? Otherwise, well, now result at least has one element, right? So result at least has one element. So now it's like we're on the second element here, and this is result so far. And we want to see if we can overlap this, if this is overlappable. So how can we check that? Well, we can check. If res at -1 at 1, so the ending of the last interval, if this is greater than or equal to the starting of this interval, if that's the case, then we can overlap it. Otherwise, we don't have an overlap, so we can just add this interval as normally, like this. Now, how do we handle the case where it's overlap? Well, remember, if it's overlap, we would just be extending the last interval to cover that overlap. We don't have to extend the start time because the start time will always be before, or at least like it will maybe be like exactly because we sorted by it. So all we need to do is extend the end time. And how do we extend it? Well, we can do it like this. The end time of the last interval is equal to maximum of the end time of the last interval or the current interval end time. So for example here, if I go to paint, if this maybe ended all the way up here, then we would not actually change the ending time. But because it ends up here, we have to change the ending time. And that's pretty much all there is to this question. Let's go ahead and click submit. And we can see we arrive at the answer. So what is the time? Well, we have to sort, so it's n log n. And for the space, we don't really have a space here because we're just returning the result, so it's just constant space. You can think of it like this. Now notice if I was to sort by this ending time, then we would have a problem and we wouldn't be able to arrive at the correct answer. So it's very important where we sort based off of. Okay, so that is the answer, and I hope you learned something.